Hello again. So today we're going to learn about empirical formulas, which is basically the opposite of what we learned yesterday with percent composition. So once again, some things you should have in front of you. This note sheet is page 8 of your packet. We're at the bottom of it now. You need a calculator and a periodic table. So we'll define empirical formula to get started. Empirical formula is the lowest ratio of elements in a compound. So for example, yesterday when we were learning how to find the percent composition, the first example you had was sugar. So if I asked you to find the empirical formula of sugar, you want to put these elements in the lowest ratio possible. So right now they're all a multiple of 6. So if we reduce them to the lowest ratio and we divided all these numbers by 6, we would get CH2O. So this would be the empirical formula for sugar. It's not always that simple. A lot of times what the problems will give you are the percentages. So what we just found yesterday. So they'll give you this, and you basically have to work in reverse to convert this into subscripts. So you'll notice here in this example we're about to do together, we have percentages of carbon, hydrogen, and oxygen, and we need to figure out what the empirical formula is from that information. So step 1, you will be given the percent composition or the number of grams. You need to assume that the percentages are the same thing as grams. So we'll go ahead, as we're going through this, I'm going to go ahead and start setting up this problem. And I'm going to list out carbon, hydrogen, and oxygen. These are the 3 elements they've given me in this example. And I'm going to write the percentages next to them. But instead of writing the percent symbol, I'm going to change it to grams, because again, we're assuming it's the same thing. So next to hydrogen, that's 8.16 grams, and for oxygen, it's 43.2 grams. All right, so step 1 complete. Step 2, convert grams into moles. Well, you should all be champs at that right now. Converting grams to moles, all you have to do is divide by the molar mass. All right, so let's go through and do that. We need our periodic table. So for carbon, carbon's molar mass is 12. Hydrogen's molar mass is 1. And oxygen's molar mass is 16. Now, I would encourage you when you're doing this, after you divide these numbers, make sure you keep the same number of decimal places that you began with. This will just make your math come out a little bit cleaner. So 48.64 divided by 12 gives me 4.05. 8.16 divided by 1, I don't need a calculator for that. And then lastly, 43.2 divided by 16 gives me 2.7. And I'll just add a 0 to that to keep it to 2 decimal places. All right, step number 3, divide by the smallest number. Now, when I say divide by the smallest number, we just converted all of these into moles. So which one of these is the smallest? It's 2.7. So we're going to divide all 3 of these by 2.7. Now let's see what we get. 4.05 divided by 2.7 gives me 1.5. 8.16 divided by 2.7 gives me 3. I know it's 3.0222, but you can just round that to 3 since it's followed by a 0. And then 2.7 divided by 2.7 gives me 1. Now, keep in mind what we're doing right now is we're trying to find the subscripts that are going to go next to carbon, hydrogen, and oxygen. We want our answer to look similar to this. Maybe not the same numbers, but that's ultimately what we want to find, are those subscripts. So the fact that we got a decimal for one of these is not good, because we want them all to be whole numbers. So this last little rule here says if you still don't have a whole number, now that just means if. You don't have to do step 4 for every problem. Sometimes after you divide by the smallest number, you're done. It really just depends on what you get. We don't have a whole number, so we need to follow this last step. If you still don't have a whole number, you need to multiply each number by a multiple until you get all whole numbers. And I'm going to add a little note to that. Start small. What I mean by that is, don't say, oh, okay, we got 1.5. Let's multiply them all by 6. All right, that is not starting small. The first number you can multiply all these by, that's the smallest number that will still give you a different answer, is 2. So if we multiply all of these by 2, 1.5 times 2 is 3. 3 times 2 is 6. 1 times 2 is 2. So we end up getting whole numbers for this problem. So we have C3H6O2. And another thing you need to check for is this the lowest ratio possible? Can I divide these numbers any further? You can't. You can't divide, if you divided this by 3, and this by 3, yes, it could be divided further, but you can't divide 2 by 3 and still get a whole number. So this is the lowest ratio possible, and so we are done with this problem. So like I said, when you get to this step 4, when you have to multiply by a multiple, some common things you'll see, like if your number is, I'm going to just make a little note off to the side here. Like in this case, if your number ends in 0.5, then the multiple you're going to want to use is 2. If you get 1.25, then the multiple you're going to want to use is 4. And if you get 1.3, the multiple you're going to want to use is 3. Now, those are the most common ones you're going to see. There are some more complicated problems, but most, if not all, of the examples you'll be given, you'll see these 3 examples, or you won't have to worry about multiplying at all. So this is day 8 of your packet, and so now you are going to complete the front of page 10, and do make sure you show your work if you want to get full credit. And please let me know if you need any help.